Hi everyone, I'm here to help you prepare for your second quarter progress check. And the first question here gives us functions f of x and g of x. They're both quadratic functions, and it's asking us to do some different operations with them. So I'm going to use the color purple for f of x and the color green for g of x, so it's really clear which function I'm using at all times. The first question is asking us to add f and g together. So I'm going to write this, I'm going to kind of do it like vertically so that I can line up all the like terms and it's really clear what you need to simplify, but it's okay if you do it more like in a horizontal way, that works too. So since I'm adding f and g, I'm going to start by writing f of x on the top. So 6x squared plus 8x minus 3. And then I'm adding g of x, which is 4x squared minus 2x minus 3. So as you can see, the nice thing about this is I lined up all my like terms, my square terms, my x terms, and then my constants. And now I just add the like terms. So 6x squared plus 4x squared is 10x squared. 8x minus 2x is 6x. And negative 3 minus 3 or negative 3 plus negative 3 is negative 6. That's all we have to do for that. The next one is asking us to subtract f minus g of x. So again, I'm going to start by writing f on the top. So 6x squared plus 8x minus 3. And then I'm subtracting g of x. So subtracting 4x squared minus 2x minus 3. Now you have to be careful here when you're subtracting because right now, the way I wrote it, I'm only subtracting 4x squared. I'm not subtracting all three terms. In order to subtract all three terms from f of x, which is what I need to do, I need to switch the sign on all three because right now I'm subtracting 4x squared, but then I need to subtract negative 2x because my function says negative 2x. So subtracting negative 2x becomes adding 2x, and then subtracting negative 3 becomes adding 3. So if I combine these terms now, I have 6x squared minus 4x squared, which is 2x squared. 8x plus 2x is 10x. Plus 10x, and then negative 3 and positive 3 cancel out. So that's all I have, 2x squared plus 10x. Last one, I have, this time it's saying subtract g minus f of x, which is a different order. So I'm going to start by writing g of x on top. So 4x squared minus 2x minus 3. And then I'm subtracting f of x. So if you want, since you know you want to subtract all three terms in f of x, change the signs as you go. So it's minus 6x squared. And instead of plus 8x, it's minus 8x. And instead of minus 3, I'm subtracting negative 3, so I end up adding 3. So again, I just switched all the signs in f of x. Now we combine the terms. 4x squared minus 6x squared is negative 2x squared. Negative 2x minus 8x or plus negative 8x, same thing, is minus 10x. And then negative 3 and positive 3 cancel. So that's all we're left with. Great. Number 2 asks us to sketch the functions using our knowledge of end behavior and x-intercepts and multiplicities. So these functions are written in factored form. So make sure you understand that this is in factored form. So since they're in factored form, it's really easy to find the zeros. So it's not like where you have to do long division to get the zeros. It's like already given to you. So for the first one on the left, first of all, let's look at the leading coefficient. Well, the leading coefficient, all we need to know is whether it's positive or negative. And since if I look at the front of the function, like right here, there's not anything there. So that means it's just positive. So it's positive. And then the degree, I need to see if it's odd or even. So I see that there's a 3 right here, but I need to add the degree on every factor for factored form. So I've got a degree of 3 on this factor, and then this other factor has a degree of 1. So 3 plus 1 means the overall degree of the function is 4, which is even. And then lastly, we need to look at the zeros. So for the zeros, if I look at the factor x plus 6, I know that this gives me a 0 of x equals negative 6. And if you kind of struggle with this, you can always set up the equation. I'll do it over here. X plus 6 equals 0. Subtract 6 from both sides, you get x equals negative 6. That's one way to think about it. The other way is just look, if you see a x plus 6, that means the 0 is opposite. X equals negative 6. And then the multiplicity, I need to think about that. I'm just going to write an M for that. The multiplicity is whatever exponent is on that factor. So that factor, x plus 6, has an exponent of 1. So the multiplicity is 1. Then I have another 0 with x plus 1. So x plus 1, that factor gives me the 0, x equals negative 1. And the multiplicity for that is 3 because the exponent on that factor is 3. And then I'm also going to make a note, since I need to know if I'm going to be bounce or go through my zeros. When it's an odd multiplicity, it goes through. So my x equals negative 6 is going to go through. And then so is 3 because so is the x equals negative 1 because they both have odd multiplicities. Again, don't look at the 0, look at the multiplicity. Here, the multiplicity is 1, which is odd, so it goes through. Here, the multiplicity is also odd, so it goes through. So we know what's happening at the zeros, but we have to also figure out the end behavior. And that's based just on the leading coefficient and the degree. So for end behavior, I already wrote down it's a positive leading coefficient with an even degree. So that means my end behavior looks like this. So I'm going to kind of sketch that onto my graph. And then I'm just going to fill in the middle using my zeros. So I know I have a 0 at negative 6. And then I have a 0 at negative 1. So negative 6 and negative 1. And then I'm going through both of them. So the way my graph is really going to end up looking is like this. So it kind of ends up looking like a parabola. And I'm just going to erase this over here because I'm not going that far. So it ends up like that because I have 2 zeros and I'm going through both of the zeros, and then my end behavior is up on both sides. So that's what my polynomial looks like. So we have another one here. I would definitely pause and try this one on your own if you understood the last example before you kind of watch me do it. But the leading coefficient, I just need to look at the front of the factors and I see there's a negative sign. So that means I have a negative leading coefficient. And then I have a degree. I need to figure out the degree. So I look at the exponent on each factor. I've got 2, 2, and then a 1. So 2 plus 2 plus 1 gives me 5, which is odd. Now for the zeros. So for the zeros, again, I just need to look at each factor. So x plus 5, that gives me a 0 of x equals negative 5 because it's always the opposite. And the multiplicity of that is going to be 1 because that's the exponent on that factor. And then x plus 1, that gives me a 0 of x equals negative 1. And that has a multiplicity of 2 because that's the exponent on that factor. And then the last one would be x equals 2 with a multiplicity of 2 because it also has a exponent of 2. So now I just have to go through and make sure I know if it's going to bounce or go through. So the odd multiplicity of 1 for the first 0, that's going to go through. And then the other two both have multiplicities of 2, which are even. So that means they're going to bounce on that 0. All right. Now let's go back and think about what our end behavior is. So this one has a negative leading coefficient and an odd degree. So that means on the left it goes up and the right it goes down. And this is something you kind of just have to start to remember. I try and always think that when it's negative odd, the right goes down and the left goes up. So it kind of looks like it's decreasing from left to right. So I'm going to kind of put those arrows on my graph to remind myself. Then I'm going to put all my zeros on the graph. So I've got -5, -1, and 2. Sorry, my zeros are really ugly. 2. And then for my first zero, -5, that's going through. And then I usually kind of pause and look. So -5 goes through, -1 bounces, and then 2 also bounces. And then it goes down from there. And that's it. All right. So this next one is a little bit thinking farther back. We need to solve these quadratic equations over the set of imaginary numbers. So there's a very good chance here we're going to get negatives under our square roots if we have an imaginary answer. So all of these, some people look at these and get kind of stuck. I mean, you just kind of look at it, you get stuck. Remember, if it's squared, that means we're looking at something quadratic. And when we're looking at something quadratic, there's many different ways to solve. So if we're trying to figure out, I always like to first see if I can solve by square root. To see if I can solve by square root, I'm going to go through and underline every time I see an x. So since I only see an x one time, I'm only making one underline in each equation. That means all of these can be solved by square root because the x can be isolated. So please do not try and factor. Please do not try and FOIL these out. Don't use quadratic formula. Don't do any of that. These all can be solved by square root. It's the easiest and best way to solve them because in each equation, like I said, I was able to underline the x only one time. So you want to think maybe do undo if it helps you make a do undo chart. But I think most of us have kind of moved on from that. So we're just trying to get x by itself. So in our first equation, x squared plus 16 equals 2. The only thing we need to get rid of to get x by itself is subtract 16 on both sides. And we get x squared equals 2 minus 16 gives us -14. -14. And then to get rid of the squared to solve for x, I need to take the plus or minus square root. Don't forget that plus or minus. Plus or minus square root. Can't forget that. So when I take the square root of x squared, I'm left with x. And then over here I have plus or minus square root of -14. Do not leave your answer like this. We're not done. We know that a square root of a negative becomes imaginary. So since, remember, I equals the square root of -1, that means whenever I see a negative under the square root like this, I can take it out by using I. So if I take out the negative, keep the plus or minus in the front. Don't put the I in front of the plus or minus. I get plus or minus I square root of 14. So I basically take the negative out as an I and leave the 14 underneath. And so that's my answer. And if you want to, sometimes I like to write it out. X equals positive I root 14 and x equals negative I root 14. You have to do that step to get full credit for a question like this. All right, second one. So I have 2 times x plus 1 squared plus 4 equals -10. So again here, always if you see like an addition or subtraction by itself on the end, you want to get rid of that first. So get rid of like what's farthest from x. So I'm going to subtract 4 first. And then you're left with 2 times x plus 1 squared equals -14. Now, I can't square root yet because I still have this 2 on the outside I need to get rid of. And I can do that by dividing both sides by 2. So we get x plus 1 squared equals -7. Now, all that's left is something squared. So that's the time where I need to take the plus or minus square root. So that leaves me with the square part goes away. I'm left with x plus 1 equals plus or minus square root of -7. So just like in the last one, if I see a negative under the square root, I need to take it out in the form of I. Don't get rid of this plus 1 yet. We're going to deal with that. So I take out I can take out the negative as an I. So I have plus or minus I square root of 7. We're still not done because x is not by itself. There's still a plus 1 next to the x. So to get rid of that, I need to set up my two separate possibilities. X plus 1 can be positive I root 7, and then x plus 1 can be negative I root 7. And then all you have to do is subtract 1 on both sides, and then you get x equals I root 7 minus 1, and x equals negative I root 7 minus 1. You don't combine these at all, so I just subtracted 1 on both sides. You don't combine these at all because one has an I and one does not. So you can't combine them. You just leave it like that. I know it looks ugly, but it's fine. All right, last one. It's the same format of an equation, so we're going to solve it with the same exact steps. I'm going to subtract 10 on both sides. So I get 3 times x plus 2 squared equals negative 27. And again, I would like pause here and try and do this one on your own after the last one we did because it's the same steps, it's just different numbers. All right, then we're going to divide by 3. So I get x plus 2 squared equals negative 27 divided by 3 is negative 9. Don't forget that it's negative. All right, then we square root both sides. And we're left with x plus 2 equals plus or minus square root of negative 9. So again, this is where we have to simplify using I. So I know I can take out the negative using I, but then I also know the square, I'll be left with square root of I square root of 9, but the square root of 9 is just 3. So I can simplify this to plus or minus 3I. Don't leave it as the square root of 9. You really need to know that that can be simplified. Now I set up my two separate equations. X plus 2 equals positive 3I, and x plus 2 equals negative 3I. And then I subtract 2 from both sides, and I'm left with x equals 3I minus 2, and x equals negative 3I minus 2. Okay, great. Let's go on to the next page. So onto the back, we need to draw these sketches based on the number and type of real or non-real zeros. I just want to make sure you know that the word non-real is the same word. It means the same thing as imaginary. Imaginary means the same thing. So if you see the word non-real, think about what that means. It means the same thing as imaginary. So the first question says, draw a sketch of a quadratic function that has 2 real zeros. Well, 2 real zeros means it's going to intercept the x-axis twice. So it's just going to be a parabola like this. It intercepts the x-axis 2 times. Okay, that's 2 zeros. The second one says draw a sketch that has 1 real zero with a multiplicity of 2. Now remember, multiplicity that's even means it's a zero that bounces. And that's going to look like this. So it's a parabola that touches the x-axis and then bounces back. So you can think of that in 2 ways. One is that it only has 1 0. There's only one intersection of the x-axis. And then you can also think about it of the double multiplicity being even, so it's going to bounce. Now the last one says draw a sketch that has no real and 2 non-real zeros. So I would kind of focus in on the fact that it says no real zeros. Something that does not have any real zeros is not going to touch the x-axis at all. That means it's above the x-axis. So it looks like this. It's never going to touch the x-axis at all. That means that there's 2 imaginary zeros. Like if you were solving this quadratic, you would get answers with I in it. So that means it never touches the x-axis. It does have imaginary solutions or non-real solutions. So that's kind of what this is saying. It's saying no real solutions. If you look at the graph, it doesn't touch the x-axis, but if you were to solve it, you would get two imaginary solutions. So that's all that that means. It's just kind of a more complicated way of saying no solution on the x-axis. All right, so number 5, this is asking us to use our calculator to evaluate each expression for the given x values. So for the first one, it's giving us an expression telling us to plug in when x is 0. So just replace the x with 0. I'm not going to write the whole thing out, but you're just replacing x with 0 in the expression. And now this one, you really don't need a calculator. Right here, this exponent 0.021 times 0, that's just going to be 0. So we end up getting e to the 0 power right here. Now e to the 0 power, or anything to the 0 power, is equal to 1. So we really just end up with 500 times 1 plus 300. So we end up with 300 plus 500 times 1, which is just 800. So this one I did without a calculator, really. You can put it in a calculator if you're confused, but if you know that you have e to the 0 power, that's going to be 1. And then you're just left with 500 times 1, which is 500. And then you add 300 to that, you get 800. Second one here, we're plugging in when x is 5. So I'm going to replace the x with 5. And now to put this into the calculator, I always start with just the e part. So e to the 0.021 times 5. And I can do that in a calculator to show you right now. So if I do that in a calculator right now, I'm just going to do e to the 0.021 times 5. All right, so that gives me 1.11071. Now, once I get that, I need to multiply it by 500 and then add 300. I mean, you can do this in steps and write down each step on your paper. That's fine, but you can also do the whole thing in the calculator. So you do the e part, then you multiply, then you press enter, then you multiply that by 500, then press enter, then you add 300, and that gives you your answer. So our answer was 800. If you round it to 3 decimal places, 855.355. And you should always round to 3 decimal places. Usually they'll tell you to, but yeah. All right, so the reason we practice that is because in these next 2 problems, we're going to be doing a lot of calculator use for this. So the first word problem says, experiments with a covered cup of coffee show that the temperature in degrees Fahrenheit of the coffee will decrease in the minutes after the coffee is poured into the cup. Use the model to answer the questions below. So luckily, you don't have to write a model. You just have to be able to use this model. So what is the temperature of the coffee at the beginning of the experiment? So you need to recognize that when it's talking about the beginning of the time, that's asking you about when t is equal to 0. So I need to plug 0 into my function. Well, if I plug 0 into my function, so t equals 68 plus 112 e to the negative 0.08 times 0. This is just like the previous example we did. I have a 0 times a decimal in my exponent. That's just going to be 0. And then e to the 0 is always 1. So that leaves me with 68 plus 112 times 1, which is just 112. And 68 plus 112 gives you 180. And then we need to add our units, which is degrees Fahrenheit, because we're talking about temperature. So that is your answer for this one. That one's easy without a calculator. Again, you can use a calculator, but it's doable without one. I'm going to leave this right here. All right, this next one is asking what was the temperature after 4 minutes. Well, that's asking us to look at when t equals 4. So this time it's going to be a little more work because we have to put it in the calculator. We're going to plug in t equals 68 plus 112 e to the negative 0.08 times 4. I'll show you one more time how to put this into a calculator. So I'll clear this. Start with the e part, just the e. So second e, negative 0.08 times 4. Enter. All right, so then I need to multiply that by 112 and then add 68. So I get 149.329 because I'm rounding up. So that gives me 149.329 degrees Fahrenheit. I know this is old stuff, but it's really just being able to use your calculator and plug things in. So, and like understand a word problem, so it's not too bad. Part C says, after how many minutes is the temperature of the coffee 140 degrees Fahrenheit? Now this is a value of T, like big T. Big T being this right here. So T equals 140. So for this, it's a little more work. We're going to have to solve for the little t, the time t, after we plug in this temperature. So I'm going to plug in 140 equals 68 plus 112 e to the negative 0.08 times little t. So I need to solve for that t. Well, the first thing you can do is you can get rid of the 68 because it's just being added at the end. So we can subtract 68, and that gives us 72 equals 112 e to the negative 0.08 t. Right, before we get to e, we need to get rid of what's next to e, which is 112. So I'm going to divide both sides by 112. I'm going to go up here. So I get, if I do 72 divided by 112 in the calculator, you would get 0.643. And then we're left with the e part, which is the tricky part. So you're probably thinking, how do we solve for the little t when it's up there in the exponent? Well, we need to use logs. So remember log base e. I'm going to make a note of this over here. Log base e is the same as writing ln. So we're going to use ln to solve this. Another thing you need to remember is that when I have a number equal to a base with an exponent like this, so I have a number equal to the base e to this exponent, that is the same as saying the exponent is equal to log base b of a. So you do need to sort of remember this. So I'm going to rewrite this in log form so that I can easily solve for t. So I'm going to have my exponent on the left side, so negative 0.08t, that's my whole exponent, equals log base b. Well, b is e. So log base e is just ln of 0.643. So again, like for this, just you kind of need to just remember that the exponent goes down to the bottom, and then you take the natural log or log base e of the number on the other side. So if you put ln of 0.63 into your calculator, there's a chance you forgot how to do that. So I'll go ahead and do that in the calculator to show you. Ln of 0.643. That gives you negative 0.442. And then we're gonna, so then we have, we'll write this out, negative 0.08t equals negative 0.442. Now to solve for t, last step, divide both sides by negative 0.08, negative 0.08. And if you do that in your calculator, you get t equals 5.523, and the time we're talking about is minutes. I'll just write it as minutes. All right, there's one more example. Again, I would pause now and give this example a shot. It's the same exact format, it's just a different scenario. This is talking about a covered cup of tea, and it gives us the temperature F of T in degrees Fahrenheit. It decreases in minutes T after the tea is poured into a cup. And we have to answer the questions. They're the same kinds of questions. The first one asks the temperature of the tea when it's first poured into the cup. Well, first poured into the cup means T equals 0. So you should plug in 0 for T. So F of 0 equals 110 plus 57 times e to the negative 0.072 times 0. Now, this is the one you can do without a calculator. The 0 in the exponent, we end up with a 0. E to the 0 is 1, so we get 110 plus 57 times 1, which is just 57, so we get 167 degrees Fahrenheit. Next one, it says determine when after 6 minutes, so that's saying T is 6. So we plug in F of 6, 110 plus 57 e to the negative 0.072. I just realized in the last one I added like the 0 before the decimal, but it doesn't make a difference. 0.072 times 6. So I'm not going to show you this in the calculator because I've showed you for all the other ones. But if you do this in the calculator correctly, you should get 147.001 degrees Fahrenheit. If you're a little off, it just means you rounded wrong and it's not really a huge deal. Okay, here we go. Last one. When does the cup of tea reach a temperature of 120 degrees? So again, this is like before. It's giving us, in this case, it's giving us F of T is equal to 120. So we're going to plug 120 in to the left side. So 120 equals 110 plus 57 e to the negative 0.072 t. First step is to subtract 110 on both sides. That leaves you with 10 equals 57 e to the negative 0.072 t. Then you have to divide both sides by 57. And you should get, in your calculator, 0.175 equals e to the negative 0.072 t. Now this is the part where you need to use logs. So to rewrite this, you would have take the exponent part right here, put that on the bottom, negative 0.072 equal t. So negative 0.072 t, that's our exponent, is equal to the natural log of 0.175, the number we have on the other side. I'm not going to show this in the calculator, but you should get, I'm running out of room again. Sorry, this is messy. Negative 0.072 t equals, if you put that natural log in the calculator, you get negative 1.74. And then you divide both sides by negative 0.072. So you get t equals, in your calculator, 24.173 minutes. So I understand if you're watching this video to get help, but I really recommend practicing putting this stuff in the calculator because you could like understand the steps, but if you make mistakes in your calculator, you're going to end up losing points somewhere, like, you know, if you don't have the accurate answers. Last page, let's get this done. So just to describe the end behavior of these functions, first of all, make a note. They're in standard form. So if they're in standard form, all we have to look at is the leading coefficient and the degree. So for the first one, the leading coefficient is 9, so it's positive, and the degree, the highest exponent, is 4, so it's even. Now positive even looks like this, up on both sides, so it's going to infinity on both sides. My infinities are kind of ugly, sorry. Next one, we have a coefficient in the front that's negative. So negative, and then our degree is 3, so that's odd. The highest exponent is odd. And negative odd looks like this. It goes up on the left, down on the right. So remember that these statements are, when it says x is going to negative infinity, that's talking about the left side. When it says x is going to positive infinity, that's talking about the right side. So in this case, to the left, it's going up to infinity, and to the right, it's going down to negative infinity. Next one, it is negative leading coefficient and an even degree. So negative even, I always remember that even means both sides do the same thing. They either both go up or they both go down. And then negative means they both go down. So they're going to negative infinity on both sides. Last one is a positive leading coefficient of 2. And then the degree is 5, which is odd. Positive odd looks like this. It goes down on the left, up on the right. And remember, when x is going to negative infinity, that's the left. When x is going to positive infinity, that's the right. So to the left, it's going down, so negative infinity. And then to the right, it's going up, so positive infinity. Okay, not bad. Now we're back to some imaginary numbers. We need to be able to simplify expressions. So for this first one, it's having us add 3 plus 6i with 5 minus 6i. So I like to just rewrite this to group the real numbers and the imaginary numbers. So 3 is being added to 5, and then I have 6i added to negative 6i. If I just kind of remember with addition, you can change the order of everything, so I'm just changing it because I know I can do 3 plus 5 is 8, and then plus 6i minus 6i actually gets canceled. And so I'm left with 8, which is real. 10i squared. Well, remember, you should always remember when you see I squared, that's equal to negative 1. So, leave me alone. That becomes 10 times negative 1, which is negative 10, which is real. 5 plus 3i squared means we can rewrite, rewriting this. So 5 plus 3i squared means 5 plus 3i times itself. So I'm going to write it out like this, 5 plus 3i times 5 plus 3i. That way I can FOIL. So for FOILing, I start with the first terms, 5 times 5, that gives me 25. Then the outer terms, 5 times 3i gives me plus 15i. The inner terms, 3i times 5, give me 15i. And then the outer terms, 3i times 3i, give me 3i times 3i is 9i squared. Right, now I have to combine like terms. If you leave it like this, you're not done. We have like terms here, 15i and 15i become 30i. And then 9i squared. Remember from the last one, 10i squared became negative 10. So 9i squared becomes negative 9 because I squared is equal to negative 1. And then 25 minus 9 is 16. And then we're left with the 30i. So this is imaginary because it still has an I in it. Next one, we're subtracting. So again, I like to group things. And then I have to remember to distribute my negative sign. So I actually might rewrite this first as leave the 5 plus 9i in front, and then I'm subtracting 5. And since I'm subtracting negative 6i, that becomes plus 6i. Now I'm going to rewrite it to group 5 minus 5 because I can combine those, and 9i plus 6i because I can combine those. So 5 minus 5 cancels out. And then 9i plus 6i is 15i, so we're left with something imaginary. I squared, I already wrote this at the top, I squared is equal to negative 1, so that's real. And then our last one is another squared, so I'm going to rewrite it as 7 plus 2i times 7 plus 2i. First, outer, inner, last. If you were confused about the last one, I'm going to go a little more in depth here. First terms multiply to give you 49. The outer terms, 7 and 2i, multiply to give you 14i. The inner terms, 2i times 7, also multiply to give you 14i. And then the last terms, 2i and 2i, multiply to give you 4i squared. So now I can combine 14i plus 14i. 49 is left. This is 28i. And then 4i squared becomes minus 4 because I squared is -1. Then 49 minus 4 is 45. And then plus 28i. And that's going to be imaginary. Great. We have 2 more to go. These are long division questions. So the first one says if x equals -5 is one solution, determine the other 2 solutions to the equation. So remember that if we know -5 is a 0 or a solution, that means we have a factor of x plus 5. It's always the opposite. So if we have a 0 at -5, we have a factor at x plus 5. So I have to set up my division now. I'm going to take my polynomial here and put it under my long division. So x cubed plus 5x squared minus 15x minus 75. I'm dividing it by the factor that I know I have, which is x plus 5. So the first step is look at the first term on the outside and the first term on the inside. I need to figure out x times what gives me x to the third. That would have to be x squared. X times x squared is what gives me x to the third. So my x squared goes on top. Now I need to multiply. So I multiply x by x squared and 5 by x squared, and it goes below. X times x squared gives me x to the third. 5 times x squared gives me 5x squared. Now I have to, since I'm my next step is to subtract. So when I'm subtracting, I have to switch the sign of both of my terms. So I get x cubed minus x cubed, which cancels. 5x squared minus 5x squared also cancels. So we actually end up with nothing below. So I need to carry down minus 15x and minus 75. So if that happens, just carry down the rest of the terms instead of just the next term. So now I got to kind of skip the making an x squared term. Now I need to make the minus 15x term. So I'm saying x times what gives me negative 15x. So x times what gives me negative 15x. Well, that would have to be negative 15. So my next term up top is negative 15. Then I multiply everything by negative 15. So x times negative 15 is negative 15x. 5 times negative 15 is negative 75. And then when you switch the signs, because you're subtracting negatives, they become adding. As you can see, everything cancels and you get 0. So that means we're left with this quadratic x squared minus 15. So to find the other 2 zeros, I need to solve this quadratic. So x squared minus 15. Really what I have is that's the factor. The factor I already had was x plus 5. This is the second factor I get, and my equation is equal to 0. So to get the other 2, so I already have x equals negative 5 as a solution. To get my other 2 solutions, I need to set x squared minus 15 equal to 0. And you should recognize that this is like a solving by square root situation. So to solve this, you can't factor it because you're missing the x term. So to solve it, we're just going to do a quick solving by square root, add 15 to both sides. X squared is 15. Then when you take the square root, the plus or minus square root, you get x is positive root 15 and x is negative root 15. So those are the two solutions that we were missing before. So it's a little uglier when that happens, but it still works. All right, last one. So if f of x is this polynomial and x equals -1 is one of the zeros, determine the other 2 zeros. So remember, if x equals -1 is a 0, that means we have a factor at x plus 1. So that's the factor we get from this 0. It's always the opposite. So -1 means we have a factor at x plus 1. So determine the other 2 zeros. We need to do our long division. So we're going to set it up. We have x cubed plus 9x squared minus 12x minus 20. And we're dividing it by x plus 1. So first steps first, look at the first factors in each. I need to know x times what gives me x cubed. That's always x squared. You should kind of remember that by now. X times x squared gives you x cubed, so the x squared goes on top. And then we're multiplying. X times x squared gives you x cubed. And then 1 times x squared gives you 1x squared. Now, since I'm subtracting, I end up subtracting both terms because they were both positive. These cancel. 9x squared minus 1x squared gives you 8x squared. And I carry down my next term. So the next question I'm asking myself is x times what gives me 8x squared? Times what gives me 8x squared? That's going to be 8x. So if I'm trying to get to x squared, I always need to multiply by an x. So x, so this becomes plus 8x. I'm going to multiply both. So x times 8x gives me 8x squared. And 1 times 8x gives me 8x. All right. Then I need to switch my signs because I'm subtracting. So it becomes subtraction for both. These cancel. Negative 12x minus 8x becomes negative 20x. Then I bring down my last term, negative 20. I have to figure out x times what gives me negative 20x. Well, that would have to be negative 20. So that's my last term. I multiply both by negative 20. X times negative 20 is negative 20x. 1 times negative 20 is negative 20. And then both become addition because we're subtracting, so the signs switch. These cancel, and negative 20 and 20 also cancel, so you get 0. Now, we have our quadratic, which is great, but we still have to factor it to find the other two zeros. So now we have f of x is equal to the factor we already knew, which is x plus 1. And then we have this quadratic, x squared plus 8x minus 20. To factor this, we need to find what multiplies to negative 20 and adds to 8. So I make a little factor tree, 1 and 20, 2 and 10, 4 and 5. And the difference needs to be 8, so that would be 2 and 10. And 2 should be negative so that they add to positive 8. So I end up with f of x equals x plus 1 times x minus 2 times x plus 10. Don't think that your zeros are negative 2 and 10. They're not. You need to write this out. These are your factors. Your zeros are always the opposite. So the other two zeros we get are x equals 2 and then x equals negative 10. So that's the answer. I hope this helped. Let me know if you have any questions, and good luck.